Perfect. Thank you so much, Dana. So hello all. My name is Nancy and I'm from Dr. Helen Cote's lab at UBC. And today I'm going to tell you a little bit about HIV, aging, and persistent viruses. Next slide, please. So to jump right into the introduction, what we know is that for the 38 million people living with HIV, they experience many factors that contribute to chronic inflammation and immunological aging, such as HIV drugs, and their environment. This leads to accelerated aging and risk of age-associated diseases occurring approximately 10 years earlier in life. Something yet to be investigated is how other lifelong infections can affect people living with HIV, and specifically CMV, EBV, HHV-A, HSV-1, HSV-2, and HCV, because all 6 of them are known to be associated with immunological aging or with age-associated diseases. And so my aim was to characterize these 6 chronic and latent viruses in a cohort of people living with or without HIV in order to begin investigating their effect on aging. Next slide, please. So I will show you all today a few different visualizations of my preliminary data set addressing this aim, of which this is the first. So shown on this slide are 2 radar plots, or spider plots as they are called, depicting HIV negative participants on the left and HIV positive on the right. Each corner of the hexagon represents 1 virus, and each point is the percentage of participants who tested positive for that virus. So a higher infection prevalence takes you farther away from the center. The yellow shape are those under the age of 30, and orange are those over 30. And the main takeaways from this slide are that for most viruses in both HIV negative and HIV positive groups, infections appear to increase with age. It also appears that CMV and HSV-2 infection occur more in the HIV positive group. Next slide, please. The next representation of the same preliminary data set is this heat map. So each column represents a virus labeled at the top, and each row represents 1 participant. A gray bar indicates the person is negative for the virus, and blue indicates positive. The top half are HIV negative participants, and bottom half are HIV positive. And within these groups, the participants get older as you move downwards. And table 1 below summarizes the numbers from this heat map, showing the percentage prevalence of each virus in the HIV negative group, then HIV positive group, then the delta difference. The main takeaway from this slide is that infection with all viruses except HHV-8 appears to be higher in the HIV positive group compared to the HIV negative. Next slide, please. The last 2 representations of the data are shown here, where the top bar graph depicts percentage of participants on the y-axis and number of viruses on the x, and the bottom scatter plot depicts number of viruses on the y-axis and age on the x. In both, pink represents HIV negative participants and purple the HIV positives. The 3 main observations are listed on the right. First, all HIV positive participants have at least 1 other virus. Secondly, the HIV positive participants appear to have more viruses, as seen on the right side of the bar graph. And finally, older participants appear to have more viruses, as seen with the upper trend line in the scatter plot. Next slide, please.
I'm going to have to go out and go back in again. It's not advancing.
Oh, okay, no worries.
Hang on. I don't know why I decided to do that. You're on your last slide, right?
Yeah. Thank you so much.
Okay. Sorry about that.
Oh, no worries. I think it's still on the previous slide. Oh,
there we go.
Yay, thank you. So after showing a few different representations of the preliminary data we have so far, I just wanted to return with ending with the big picture. So starting at the top, what we know is that people living with HIV experience faster biological aging and are at risk of age-associated diseases earlier in life. But the question is, why does this happen? Next, we encounter the knowledge gap, which is that we don't know what is the effect of having multiple persistent lifelong infections on aging, especially in people living with HIV. And this is what my study aims to address. And finally, the three main contributions that I hope will come out of this project is first, hopefully we'll have a better understanding of this phenomenon of accelerated aging seen in people living with HIV. Second, I hope that it will provide a basis for future research, some of which is already being undertaken by fellow grad students in the Cote Lab. And finally, I hope that we can ultimately inform future treatment or prevention strategies to help those living with HIV in our community. With that, thank you all so much for listening, and I'm happy to take any questions.
Thank you, Nancy.
Thank you, Dana.
So we'll get some questions going. I just had a question for you. Just
Yeah.
curious about the accelerated aging phenomenon and what's the contribution of the antiviral therapy to that phenomenon? Is that understood?
It is not, it's not well understood. No, but there's some research being done right now in my lab, and right now we're looking at the contribution of the antiretrovirals to anti-DNA mutations, and it's known that it's known to have an effect on mtDNA content, mtDNA mutations, and that may be a contributor to aging, and so we'll have to see on that, but yeah.
Thank you. Other questions? Oh, I see Dr. Prydale's put himself on camera. That must mean he has a question.
Sir, are you surprised at all that the older you get, the more viruses you have?
No. So that's actually part of my hypothesis, was that I hypothesized that age, like older age and positive HIV status, would be associated with more viruses.
So that's pretty well established already for any of those
Yeah.
herpes viruses that you've seen.
Mm-hmm.
So that's not novel. What about even sitting in a hospital for longer periods of time, which is what HIV people are certainly exposed to? So that's also known, isn't it? The longer you spend in a hospital or in a doctor's office, the more likely you are to have any of those herpes viruses, even Kaposi sarcoma virus, HHV8, right?
Mm-hmm.
So how are you going to fit all this all together? This is really cool.
Mm-hmm.
I'm just wondering how you're going to fit all this together.
Yeah, so it's with a project like this where it has so many sort of avenues in which you could tackle it. Like you could tackle it from the perspective of how do these people accumulate so many viruses and what contributes to them accumulating this many viruses. I'm sort of taking it in a different direction where I'm just looking at just the number, and then the bigger question is actually relating it to markers of immunological aging. So I'm just going to be taking the number of viruses. I'm not going to delve into, how or why maybe they got that many viruses, but I'm just taking the number and I'm going to relate it to markers of aging, such as leukocyte telomere length.
So a synergy toward aging.
Yes.
Terrific. Thank you very much.
No problem. Thank you for the question, Dr. Prydale. Nice to see you too.
Okay, any other questions? All right, thanks, Nancy. That was very interesting.
Thank you, Dana.